Okay, guys, let's do some inequalities. It says, consider the equation x squared is equal to 3x plus 4, where x represents a real number. Are the expressions x squared and 3x plus 4 algebraically equivalent? Okay. Are those equal? We just talked about statements, true facts, and stuff like that. Can that be equal? So what that means is for anything that we plug in for x and we square it, can we get 3x plus 4 to equal it? So let's just try. Let's do a number like what if we did, well, right now we would say no, it's not, because we're not given a number for x. So is it algebraically equivalent? No. But what if we plugged in a number like, no is the answer to that, but if you plugged in a number like 4, if it said x equals 4, well, 4 squared would be equal to 3 times 4 plus 4. Is that true? Yeah, 16 is equal to 12 plus 4. So that would equal 16 equals 16. Yes, that is. But just by speaking algebraically, no, it is not equivalent. All right. Let's see what the next page holds. Okay. So the next page says the following table shows how we might sift through various values to assign to the variable symbols in the hunt for values that we would make the equation true. So that was the equation we were talking about just earlier. I said this would make it true, but all the other ones were false. Okay. If you plug in all those numbers, they're false. And it gives you this image here. We plug in 2 and 3 and we try all these other numbers here. Nothing actually works except for the solution 4. Okay. So that's the only solution there to make a true statement. Now we consider the equation 7 plus t equals 5. And it says 7 plus 0 is equal to 12. That is false. Well, what about if we plug in a 4 for p? 7 plus 4 is 12. That is incorrect. Right? So that's another false. What if p was 1 plus the square root of 2? So we'd have 7 plus 1 plus the square root of 2 equals 12. Well, that's not going to be the case because x plus the square root of 2 is not equal to 12. So that's going to be false. What about 1 pi? Is that going to be? Well, I mean, not 1 pi, but 1 divided by pi. 7 plus 1 divided by pi, is that equal to 12? Well, that's going to be 1 over 3. So 7 plus 1/3 is not equal to 12, right? So that's another false. What about 5? 7 plus 5 equals 12. Yes, that is a true statement. So that's the only true statement. All right, let's keep going. This says the solution set of an equation written with only one variable is the set of all values one can assign to the variable to make the equation a true statement. So the only solution is the one that makes it a true statement. Any one of those values is said to be a solution to the equation. To solve an equation means to find the solution set for that equation. Now, we're used to just having one answer being correct. You're about to get into some that there's more than one answer. Okay, A can be more than one thing. For example, A, is the square root of A equal to 25? Well, sure. because we would say a squared is equal to 25. How do you solve that? Well, you would say the square root is a equals to 5. But square root would have to be a, when you square root something, it's going to be plus or minus. You say, well, how's that true? -5 times a -5. That's a positive 25. Same thing for 5 times 5. That is also equal to 25. So a would have to be plus or minus 5. Because if you square a -5 or you square a positive 5, you get 25. All right. In words, a squared is equal to 25 has solutions a and -5. In the set notation, so we're talking about set notation. So how do you write the answer? You would say -5 and 5. And if you graphically do that, you would show the answers to be 5 and, or -5 and 5, because those are solid dots. That tells us that it's the number included on the number line. Look, in graphical representation, a solid dot is used to indicate a point on the number line that is to be included in the solution set. The dot, when physically drawn, is larger than the point it represents. One hopes that it is clear from the context of the diagram which point each dot refers to. And what that means is, see how the dot is bigger than the line? So that kind of looks like it's a little bit less than 5 over here and a little bit greater than 5 over here. But you know, by putting one dot on there, that it only represents that number which is included. All right, curly brackets indicate we're denoting a set of numbers. For this example, we have -5 and 5 to make it true. When the elements are listed, they are listed in increasing order. Increasing order. Sometimes a set is empty or it has no elements, in which case the set looks something like that. It's just an empty set. We often denote this with a symbol of 0 with a line through it. That's an empty set, or what's called null. Null is another word for empty. All right. Okay, so here we go. Solve for a squared is equal to a -25. What can you square to get a -25? Well, let's try -5. And we already know that -5 times -5 is a positive 25, right? So this, you cannot have a negative inside the square root right now. You can't do that. That is an irrational number. Actually, it's going to be an imaginary number, but you'll learn it by Algebra 2. You may learn it. You should learn about imaginary numbers in geometry, but anyway. All right, so this is a null set. There's no solution for this. So how would we do that in words? We would just simply say the solution should be a 0 or an O. The solution set is empty. Okay. In set notation, we just leave it empty like that, or we could write our empty set notation. And graphically, we write it down through here like this, and we would say oh, that's wrong. Oh my goodness, I'm going crazy here. What happens when you try and get in a hurry? -1, -2, and you wouldn't put anything. You would not have a dot on this line. So there's nothing there. we cannot represent it graphically. All right, let's do another one. Depict the solution set. All right, so we already know this. We've already done it. We said 7 plus p is equal to 12. We subtract 7, p equals 5. So in words, we would say the solution is p equals 5. So we would say 7 plus p equals 12 has solution of p equals 5. There we go. Set notation would just simply be 5. Graphically, I try and just put it in the middle somewhere. I don't really care where you put it as long as you have it on here. My goodness. And you would just have the solid dot just like last time. That shows that p is equal to 5. Okay. Solve x over x to equal 1. For x over the set of positive real numbers, depict the solution set in words, in set notation, and graphically. Now, you know that if we plug any number in for x and we put it over itself, that's going to equal 1. So it really does not matter what you put in there. If you can see this, it's all true. Everything is true. So how are we going to write that in words? And we would say the solution set is all positive real numbers. Okay, and we say positive because it told us that it had to be positive real numbers. Okay, set notation though would look a little bit different. Okay, we would say x is of real numbers when x is greater than 0. So that makes it positive, right? If it's greater than 0, real solutions that are greater than 0. Now, graphically, there's some of the stuff that y'all struggle with that we've talked about. Okay, 1, 2, 3, 4, 5, doesn't matter. We put a open circle because it's got to be greater. Oh, I don't need to do that. It's got to be greater than 0. So we're not going to count 0, but we're going to say it's everything to the right of 0. Okay, and that's indicated by filling in the arrow and making a bold line on top of it. So it's everything greater than 0, not including 0. All right. Exercise 3. Now it says over the set of all non-zero. Now why can it not be 0? Because you cannot have 0 in the denominator. That's the reason why it has to be non-zero real numbers. Okay. So it's just doesn't have to be positive. It's just got to be non-zero real numbers. So in words, we would say all. I need to say the solution set. Sorry. Solution set all non-zero real numbers. Okay. Set notation what's that going to look like? Okay. We would just say something that says, as long as, let me write a little bit bigger. X, as far as real numbers, when X does not equal 0. So they can be negative this time, they can be positive this time, they just can't be 0. So what would that look graphically? I'll plug 0 here, 1, 2, 3, 1, 2, 3, it's -1, -2, -3, 1, 2, 3. We can't have 0, but we can have everything to the positive and everything to the negative, but it cannot be 0. That works. 12. Solve. Oh, let's solve this, and I bet it's going to want. No, just wants us to solve it. Okay. So for us to solve this, we would say what? Solve for X. Well, first we'd have to do distributive property here. So that'd be 3x plus x squared is equal to 3x plus x squared. Now, that is a true statement. Yes. Whoops. Check mark. True statement. Okay. And what that means is that we can plug in any number whatsoever. Any number, and it's going to be correct. Okay. So if you ever see on a computer something that looks like, it's going to look something like that, something kind of fancy like this. Okay. That means basically all real numbers is a set notation. This would be all real. All real numbers. And that's including 0, that's including negative numbers, that's including positive numbers, everything. So that would be, oops, that would be, yes. Okay. Now, what is it going to look like for this one? All right. So this is going to be the same thing. A plus a squared is equal to a squared plus a. Is that correct? Yeah, it is. So we would say this is true. This is let's just keep it simple and say all solutions let's just say all solutions that are real numbers. So 0 will work again, right? So then in set notation, we would write that fancy little R. Okay. And then we could also just do everything on the number line. So fill it all in. Doesn't matter what numbers you put on there. It just, you got to fill it in. All right. Let's see here. Okay, so this says identify the properties of arithmetic that justify why each of the following equations has a solution set of all real numbers. Okay, so to justify this, I just told you earlier, that's just the distributive property. Distributive. That's the property. That's all it wanted you to do. Okay, so what happens down here? This would just be the commutative property, right? Because it's just written backwards now. Commutative. And here, it's just grouped differently. So we know that to be associative. Hold on, is that just grouped differently? You could call that a bunch of different things. That could actually be distributive, commutative, and associative. Yeah, so we're just going to call it associative because we can call it that. Associative. Be distributive as well, though. Okay. Now let's get some actual problems here, I hope. Okay. Create an expression for the right side so that the solution set of the equation will be all real numbers. Okay. So how would it be all real numbers? Well, we can always just write -5 plus 2x. Right? That's the same thing, makes everything real. That's probably going to be the easiest thing for you to do. Okay. For B, we could call this x times x plus 1, because if you do distributive property, you're going to get the exact same thing there. All right, what about this? So this is just multiplication, so we can maybe say, it doesn't matter. Just as long as you have x, z, y, and 4 in there, that's all the same thing. For D, okay, we can go ahead and do that. So x plus 2 times x plus 2. That'd be x squared plus 4x plus 4. So if we were to write that in there, that would make both sides equal each other, which would give us all real numbers. All right, let's see here. Example 6. Solve for W when W. Okay. So here's our inequality. We can't make it equal 4. We have to make this side be greater than 4. Okay. So let's just do this. So W, we would just subtract 2. W has got to be greater than 2, right? If you subtract that from both sides, you'll get W is greater than 2. So we would write that as 2, but it's got to be greater than. It cannot include 2. So we'd have an open circle, and we'd go to the right of anything that would work. So we would say, for the solution set, we would say W must be greater, and nothing's on the right, than 2. Okay, and for the notation, it would have to be W for real numbers. W's got to be greater than 2. And there's your graph. Solve B, B squared has got to be greater than or equal to 9. Okay, so it's got to be greater than or equal to 9. So let's solve it first. For B squared, we would do the square root and the square root. So B is going to be greater than or equal to, and we said the plus or minus 3, right? It's got to be plus or minus. So how are we going to solve this? We would say B is greater than 3, and B's got to be what? I'm sorry, greater than or equal to, or greater than or equal to negative 3. Is that a true statement? Because you got to think about it. Okay. If I say greater than or equal to a negative 3, if I plug in a 2 squared, is that greater than or equal to 9? 4 greater than or equal to 9? No. That is not a true statement. So what is that going to be? What is that going to mean here? Okay. I think we're okay with B's got to be greater than or equal to 3, but B would have to be less than or equal to 3, negative 3, sorry. So if I said less than a negative 3, that'd be a negative 4. Negative 4 squared is greater than 9. Yes, because 4 times 4, negative 4 times negative 4 is 16, and that's greater than or equal to 9. That is a true statement. So how would we describe that on a number line? Let's do it right here. So that would look like this. Negative 3, 0, 3. Okay. We'd have to say or equal to, right? So it's equal to negative 3, anything to the left of it on the number line. And if we said 3, anything to the right of it. That's the way it would look. What is the solution to set 2 sticks length, sticks of length 2 yards, 2 yards, and L yards make an isosceles triangle? Describe the solution set in words and on a number line. So 2 yards and 2 yards. That's talking about what is this? What can this right here be? This number here. Well, if you think about it, can it be 0? No. So it's going to have to be greater than. Well, it's not greater than. Yeah, so that would be greater than. So let's just call it L has to be greater than 0. Okay. But if you know properties of isosceles triangle, if you add these two numbers, the other one has to be less than the sum of the sides. Okay. So that's what we would say. L must be greater than 0, but less than 4. Anything about it. If these isosceles triangles, if this was something like this, it's still going to be less than 4. It can't be 4 because 4 would be if both of the sides were laid out side by side. Okay. If it was laid flat, that's what it would have to be. So how would we draw this graphically? Well, it's got to be greater than 0, and here's 4. But it's not going to be either one of those. So it's just going to be everything in between 0 and 4. Okay. I think maybe there is this to kind of help you memorize all this. And there you can be working on your homework.